Okay, so welcome to Vaayusastra's Future Scientist Meet, chapter number 29. So today is like after all these floods and all over, today is like very calm. I felt a slight happy sun, so that felt nice in Chennai. And even though all this happened, our chapter 28 and 29 happened. So that's a good thing. So today, so we have 4 presenters who are going to do their present their research works, out of which one is a new presenter. That's our Yashwin Tilbert. He is a level 6 offline module student. So level 6 in offline is almost like 2 years. 2 years of course. For example, every one level for student to complete, they need to spend 3 months. So 1 year we can complete maximum 3 levels. So he completed 6 levels. So almost 2 years. So he is almost equal to second year of aeronautical engineering. So he is building his own cube satellites currently. And next level he'll be building rockets. So yeah, so that's like a mini introduction to new presenter. For those who are watching, what is Vaayusastra? What is this future scientist meet? Why we are doing this? So let me give one brief introduction. Vaayusastra is an IIT Madras incubated and funded startup, and our primary job is to spread the awareness of aeronautics and aerospace among school children and college students using unique methods. Unique in the sense holistic method. We using storytelling methods to teach children. I use a lot of mythological stories to educate children in the field of aeronautics and aerospace. And for college students, we use totally hands-on methods. And why we do this? For example, I love aeronautics and aeroplanes when it's still from age 5, but I waited for 18 years to even study the basics of aeroplanes, like parts of plane, how to control the plane. So, but after when I was in second year or third year, I realized why I had to wait for 18 years to learn this. It can be taught to one 8-year-old in a simplified way. So this is one of the ideas which popped up in my mind during that time. Then after completing my master's degree, so it happened. It became Vaayusastra Aerospace. Then IIT supports these kind of innovative ideas. And now Vaayusastra is started in 2018. We are like 3 years, 3.5 years. We like completed, and we faced a lot of struggles in the sense it's a totally offline and hands-on design. It was made. So pandemic, we were forced to create something, but at start I was quite skeptical because I'm not so big fan of online modules and education design. But my mentor Ravichandran sir suggested, why don't you come up with one new module? So I started researching about life of Elon Musk, life of Wright brothers, life of Abdul Kalam. So yeah, there's a moment in their life which triggered the spark. So I thought, why don't we create so many Abdul Kalams, Elon Musks, or Wright brothers with that the similar kind of design? So we created something called Trigger the Spark. And we started as one module. Students started asking for more and more modules. So totally 9 modules are there. And after 9th module, even the students still are asking after this. Then I said, okay, what to do? I created one young researcher school where we started training children to do presentations, to do research work, how to do research paper, study, how to build products, all these things, how to start a startup, all these things we started training. And after 6 to 8 months of training, accidentally one day I clicked the live button. So we went on live. So I thought, oh, okay. Then we got audience from few countries as well. Okay, I thought this is a very good way to exhibit their skill sets. So it started like that. Then it started. So today, almost 29 weeks in the 15th week, it means like almost 4 to 5 months. Okay, 3 to 4 months. So we are continued to do it. We never missed a week. So, and we started seeing beautiful results. So a lot of students started their own channel, YouTube channel, own companies, started writing their own books, and the numbers are more than 20, 30. And currently we have more than 80 students in our research group. So I'm currently creating like hundreds of Abdul Kalams. I'm so proud. Okay, that's a brief introduction of what Vaayusastra does, part of this young researchers crew or future scientist meet. Okay, let's not delay. Let's go to our first presentation. So this presentation is by someone very special to Vaayusastra on a whole, because this student, she uh, she with her amount of passion, she just impressed me always. But accidentally one day I told her, after teaching her how to access Chandrayaan-1 images, she accidentally generally asked me, Jagu, shall I collect all the 1600 crater images? Okay, do it. Then she took some 4 to 5 months of time. And she finally one day came, Jagu, there are like 1600 crater. And she showed me, and it's like I was, oh, okay, this is like some college level kind of work. Generally, I was telling in one of our events, there one magazine editor noticed this. She published in her magazine mentioning this student did this. Then that was noticed by one book publisher. Now this work, this hard work is now getting published. And yeah, that's Bhairavi for you. Let me introduce Bhairavi. Bhairavi is grade 6 student from Sreevatsa Viswanathan Vivekananda Vidyalaya, and she is currently part of research target space company as a research scientist and development engineer, and she is going to present on this topic, ultra knowledge. Yes, Bhairavi, you can, the stage is all yours.
Yeah, sir. Can you please allow screen sharing?
Yes. Yeah, you can share now.
Okay. So, thank you, sir.
Jagu.
Sorry, Jaggu. Hello, everyone. I'm Bhairavi, and today I'm going to present about ultra knowledge. So there are 3 questions. I will be answering those questions. Yeah. So the first one is, can there be life and existence outside of Earth? You can share your thoughts. You can interact.
Shall I tell Bhairavi?
Yes.
So it might be and might be not be, because in some planet there is no life in our solar system, no, except our Earth. In any other planet there is no life, but maybe it can be. And some people presented about this exoplanet. So exoplanet there is life, but satellite need to receive. That satellite need to receive and check up. So maybe it will be the answer, but some planets no, we are checking. For an example, Mars colonization.
Okay. Yeah, you're
Actually,
right.
Bhairavi, I just want to ask you one thing.
Yeah.
Are you specifying that only it can be like little like human type, or it can be like smarter than humans? Because if it is smarter than humans, it is yes, they can even live in Jupiter.
Yeah, it can be smarter than humans.
Then I guess so, yes, because
Okay.
they can even live in Jupiter then.
Okay. Yeah, there might be life and existence outside of Earth. Numerous researchers assume that we are not alone within the universe, which there may exceptionally well still be life exterior of soil among a few of the other billions of planets. Okay. The next question is, why is the sun's outer layer too hot? Any guesses?
I think so. The sun core might be so hot.
Yeah. Why?
Because sun, no, it's obviously it's like a lightning fire. Okay, so it's like a fire and it spread light for all the planets in our solar system. For all the planets, so it could be that the sun layers too hot because the core will be so hot because of the fire. It might be so hot.
Okay.
Can
It's
I
because
say why?
yes.
Okay, then I said I guess so because the it is doing nuclear fusion. It is also having a lot of solar flares, which can increase the temperature, and also since it is using something called nuclear fusion, it's the atoms combined. It can be the reason. That's
Yeah.
how they produce energy, and by that energy that is making the outer layer also hot.
Yeah. Okay. It's because gases in this layer shine ultraviolet wavelengths. The outermost atmospheric layer is the corona, which gets really hot, almost 2 million degrees Fahrenheit. Actually, Darsh's answer is right. So the third question is, will they ever be able to travel through time? What do you think?
No, the answer is because Albert Einstein told that time is not in space. Okay.
Okay. So
Actually, we can go if we're able to go faster than the speed of light.
Yeah, so if we go faster than the speed of light, we can check it. Whereas we can also research on that. Okay, like duration wise, like if you take London and India, no, I told Albert Einstein told, but I'm just thinking about that. That's my view. So so when you are in India, for an example, when you are in India and London, what is the difference between the time? It's as usual 4.5 hours. So like that, we need to do time calculation and we can find the time, obviously.
yeah, okay. Well, maybe we will be able to travel through time. So we can travel back. It's theoretically possible. So according to a life science interview with Professor Charles Liu, astrophysicist at the City University of New York, in this four-dimensional space-time, you're only able to move forward in time. Regardless, scientists are continuing to develop proposals for time travel, including an approach that involves the use of wormholes, which are essentially tunnels that connect different regions of space-time. Okay. So thank you for listening. You can ask all your doubts in the quiz. And I have a little announcement to make. It's that I'm starting my new company. I'll be doing a presentation next week for introducing my company.
Oh, nice, nice. So
By the way, you are in
starting the
target
company.
space, no?
Yes, but after that presentation, I'll be leaving target space.
Okay.
Okay.
Yeah.
Okay.
I'll share the quiz link, sir.
Okay. That's good. So Bhairavi announced she's going to start her own company. So whoever's researchers watching this, so if you can want more details, you can get in touch with Bhairavi. Okay, the
So this
link,
is the code to join the quiz. I put it in the chat.
so quizzes.com. So you can share the
Link is
link
there.
directly.
The quizzes
Bhairavi,
are
can you send the
Link.
Yeah, I'll send the link.
Okay.
Yeah.
Yeah, she showed the link. I'll put it in live as well. Students, you can join the quiz link. Where you can share. Okay, super. How many? 6 joined. Let's wait for 2 minutes.
Yeah.
Yeah, you can post it in school group as well. Which one? So if you have any feedbacks, any questions regarding
Yeah, the questions you can ask it in the quiz itself.
oh,
If you have any suggestions, you can tell me.
yes, Anish, you can.
Okay. Mm.
I think wait for 1 or 2 minutes, you can start.
Yeah, sir.
10 now.
Mm. Yeah. And has joined.
I think you can start.
Yeah, sir.
So, go.
So the quiz has started.
Yes. So you can read out the question.
Yeah, the first question is, for years, scientists have debated over the question of why the sun's outer layer is dashed on its surface. This is very easy.
Much hot, much hotter, much colder, ordinary, all of this.
Okay.
Wow.
Everyone has given the correct answer.
Who is that one more? Yashwin.
Sharon and Yashwin has not answered yet. And Satyaki.
Yashwin, did you answer it?
I'm going to the
Then you
next
should
question.
not know the answers. So,
Oh, who said this? In this four-dimensional space-time, you're only able to move forward in time.
who said this?
Albert Einstein, Srinivasa Ramanujan, Stephen Hawking, Charles Liu. And this is
Yeah,
also very easy.
All four are like very.
Riya is leading, followed by Vignesh.
Don't show the answers. Don't show the answers.
Oh, yeah. Yes. I'm going to the next question. Another popular approach is through the use of dash strings, which are tubes that loop around the entire universe. So the options are cosmic, space, none of these.
I think we discussed this in set 2 on the Tesla story.
One more thing, you can't ask your doubts here. You can ask your doubts in the chat box.
The timed, okay, then you can show
Yeah.
that.
Still, Riya is leading, followed by Anish and Naman. Okay. Next two are not exactly questions, but still you can answer them. Do you think aliens are real?
Actually, you should not put the chart here. You can show it once the timer gets over. That's the
Do you have any doubts? That is the next question.
Yeah. Okay.
No.
I can see so many no's. So that means they watched it fully. Anyway, it's a very neat and simple professional
Two participants are not answering at all.
because they may be new
Yeah.
or so yeah, Tarun always like he faces
Arun and Sri
yeah,
Sanjana.
I think they are new to this. Okay. Let's see the leaderboard. Yes.
Yes. Okay. What happened? Yeah. Priya is
Nice.
first, Anish is second, and Naman is third. Congratulations.
Yeah, Anish Naman. So leading the leaderboard. So out of Ria got 5 out of 5. Anish.
Yeah.
Oh,
Anish got one question wrong.
Vignesh missed one.
Yeah.
So we can also Vignesh missed it by very close margin. Even Matesh also.
Yeah, sir. So the toughest question is this. Who said this? In this four-dimensional space-time, you're only able to move forward in time.
Yeah, the moment you say space time, all of them will start clicking
Giving,
Einstein.
yeah.
And even yeah, Stephen Hawking as well. But Einstein holds more fans.
Yeah. So this is the longest question. Yeah.
Well done, Bhairavi. That's an amazing presentation followed by a neat super quiz. Well done. And the announcement also nice. So
Thank you, sir.
Bhairavi announced she's starting her own firm. So whoever want to know more details about it, kindly message her. You can share your details, Bhairavi, in the chat box. Okay.
Yeah, sir.
Thank you. Let's give a huge round of applause for Bhairavi. All of you can unmute and get clap.
Thank
Let
you,
me
sir.
hear some sound. Go unmute and get clap.
Amazing
Unmute le clap
presentation,
பண்ணணும். Don't mute
Thank
and
you,
clap.
Satyaki.
Unmute yourself and clap.
Yeah.
So all this are like very
Amazing,
comfortable with
sir.
this. The clap பண்ணலாமா இப்போ 1 2 3 go unmute first.
Thank you, everyone.
Beautiful. Nice. Thank you, Bhairavi.
It's amazing and short presentation.
Kindly
Thank
also
you.
put your feedbacks in YouTube live as well because this is a memory. Whenever we can watch it back, it gives on nice positive feel. Whenever we can go back in time and watch. So that is the main reason behind it. Thank you so much. Let me invite our next presenter, our series man, the outer space research scientist. So this is almost the 12th part, 12th series, 12th episode, I can say, because each episode is almost 20 to 30 minutes or more than that. And this is the 12th episode. So this means you should know how much this boy loves the outer space, the solar system and beyond. I can see one small Einstein or one small Hawkins is budding. So I can expect more from this boy. Let me introduce him. This is Naman Naitak Sahu. So he is a grade 5 student and he is from this company Aerospace Now and he is a research scientist and he is from the school Ekya school Pvt. And he is going to present on this topic, planets of the solar system and beyond. And as I mentioned, this is part number 12. So soon we'll be putting all Naman's videos as a single, either a single video or a separate playlist for Naman itself. So that will happen. So we are doing that. My editing team is working on it. So Naman, the stage is all yours.
Thanks a lot, Jagu. So let's begin the presentation. Okay, wait, okay. Okay. So, planets of the solar system and beyond, part 12 by Naman and Aerospace Now, which is me. So this is a series where I talk about planets. Or gone further to the exoplanets, which I have reached, surprisingly, very quick. This will go on until I run out of planets to discuss on. Thank you, and I enjoy. I might do the presentations in between. So, rules all are present. No interruptions. Questions at the end of the presentation. Interactions are clearly allowed. Raise your hand to interact. Feedback and suggestions at the end. Now sit back and relax while I present. Copy it. So, let's begin. Kepler 10b. Pretty straightforward. What kind of an exoplanet is Kepler 10b? Kepler 10b is the first confirmed terrestrial planet to have been discovered outside the solar system by the Kepler Space Telescope. Discovered after several months of data collection during the course of the NASA-directed Kepler mission, which aims to discover Earth-like planets crossing in front of the stars. The planet's discovery was announced on January 10, 2011. Kepler 10b has a mass of 3.7 kilo, this equation, and 0.42 Earth masses and a radius of 1.47 Earth radii. However, it lies extremely close to its star, Kepler 10, and as a result it is too hot to support life as we know it. Its existence was confirmed using measurements from the W.M. Keck Observatory in Hawaii. Kepler 10, the star that hosts Kepler 10b, is located 560 light-years from the solar system in the Draco constellation. It is approximately the same size as the Sun, with an estimated age of 12 billion years. Planet Kepler 10b was the first planet to be discovered in the orbit of its star. For this, it was designated the star's B planet. Star in turn was named for the Kepler mission, a NASA-led operation aimed at discovering terrestrial planets that transit or cross in front of their host stars with respect to Earth. This planet's discovery was announced to the public on January 10, 2011, as I said. So let me have a bit of a continuation. The transit method of discovering exoplanets relies upon carefully monitoring the brightness of a star. Now this part is for anybody who doesn't know what the transit method for finding exoplanets is. There are 4 other methods. I'm not going to explain them, but I'm going to name them out. Gravitational microlensing, astrometry, direct imaging, and radial velocity. And surprisingly, to find Kepler 10b, we used 2 of these, transit and radial velocity. So, if a planet is present and crosses the line of sight between Earth and the star will dim at a regular interval by an amount that depends upon the radius of the transiting planet. So, let me put this in a diagram. This is the star and this is the exoplanet. So, we know that any planet, if it's an exoplanet or a planet of the solar system, it will always revolve around the star, supposed to orbit. So what happens is that there will be some source of light that will fall right from the star. It will show its brightness, and then as soon as the planet comes in front of the star, there will be sort of an area that is dim in light, or it's because planets are opaque and the planet blocks the light that the star gives. So basically what happens is, with that dimness, we are able to locate where the planet is. We are able to find its distance from the star depending on how dim it is, and also we can find its orbital or rotational period. So let me just so in order to measure the mass of a planet and rule out other phenomena that can mimic mimic the presence of a planet transiting a star, candidate transiting planets are followed up with the radial velocity method of detecting extrasolar planets. Kepler-10b's discovery was based on 8 months of data collected with the Kepler telescope from May 2009 to January 2010. The planet's first transits were observed on July 2009. According to the collected data, Kepler-10 dimmed by one part in 10,000 every 0.83 days. Kepler-10 was the first star in the field of view of the Kepler telescope identified as capable of harboring a small transiting planet. It was considered a high priority target for ground-based radial velocity observations intended to confirm the mass of Kepler-10b. Radial velocity measurements with the Keck-1 telescope, taken intermittently between August 2009 and August 2010, revealed a periodic Doppler shift, or basically radial velocity, in the spectrum of Kepler-10, consistent with a planet of the nature observed by Kepler, confirming the planet's existence and allowing its mass to be determined. A little more information. On January 13, 2011, 3 days after the planet discovery was announced, The Economist published an article suggesting Vulcan as an unofficial name for the planet, after both the hypothetical planet and the Roman god of the same name. So The Economist published a suggesting name for the planet, but in September 2011, the detector of secondary transit and phases was announced. This allowed to determine the temperature and albedo of the planet. Basically, albedo is the amount of light that is reflected by the planet, and the light is coming from the star, obviously. This is the first terrestrial exoplanet with observed phases. Detection of phases was possible due to the extreme day or night side temperature variations, the amount of starlight the planet receives due to its proximity to the host star. Kepler-10b's discovery excited astronomers, who hoped to use data about it to inquire the formation and structure that terrestrial Earth-sized planets tend to have in common. So technically, they were discussing about thinking to colonize it. But Diana Valencia at the University of Côte d'Azur in Nice, France, considered the planet more of a supermarket than a super-Earth, granted its physical characteristics. Kepler-10b is most noted for its rocky surface, and the average density of it is 6.46 to the equation 0.70 grams centimeter cube. So it orbits the star Kepler-10 in less than a day. 20th of from Mercury to the Sun. Surface temperature on the star-lit side is approximately 1,833 Kelvin, which is as hot as a blast furnace and hot enough to melt iron. I'm pretty sure we have heard what is the temperature melting point of iron. I did discuss this in my previous presentation, my material alloy theory. Hope you remember that. So, can Kepler-10 be colonized? At such close range, as I obviously did say, Kepler-10b does not lie in the habitable zone, the region in which liquid water could exist on a planet's surface. It is too close, other than other examples of planets that are farther in the habitable zone, farther than the habitable zone area. But this is too close. So, therefore, it is unlikely to any life exists on its surface. The planet is also tidally locked to its parent star, meaning only one side ever faces the star. That means it doesn't even have any rotation, it only revolves. And let me tell you one thing. In my last episode of Planets of the Solar System and Beyond, or you could say my last presentation, I did say about Kepler 22b that it could have extraterrestrial life, and it could answer the first question in Bhairavi's presentation. Could there be extraterrestrial life outside Earth? I would say yes, because Kepler 22b has the capability, because it is clearly colonizable by all means, even though there's more candidates. So it's quiz time, and thank you. Any doubts, please do share your feedback and suggestions. I will just prepare the quiz.
This time,
Alright.
do you have any doubts related to the
Anna Kepler 22, Anna Kepler 10b is colonized, yes or no?
Yes, it is colonizable by all means. It is in the habitable zone. And it possibly has water. I did say that in the last presentation.
Thank you.
Last
It's
presentation.
amazing presentation also.
Thank you. And any other doubts apart from this?
So those who did not get it, you need to watch it 1 or 2 times. So this is like a 12th part. So there's as he said, he explained about memory alloys in one session. So you need to go back and learn that and come. Like the transit method.
Anna,
He also explained a few times before, like how many ways we can find exoplanets, all these things. Okay, so the quiz link. Okay, so it's set to.
Okay.
in near-pond
The
quiz
quiz link is ready. Okay. You can join quick. Preparing this. Alright. Let me share screen.
So posted and quiz link posted and YouTube live as well.
Anna ID.
ID.
No need for ID.
Just need to click the link.
Yeah. Just click the link.
Can share the screen so that.
Okay, I'll share the screen. Oh, boom. We'll wait for those characters to come. First one.
Oh, Adrit.
I won't show the preview yet.
Anish.
Anish.
It looks like an alien. But Matesh is a panda.
3 people are still choosing their character, and because you can see it shows 6 here. That means, yeah. Ranadeep came in.
Ranadeep is a cat. What is that?
Yeah, it's like a frog, maybe.
Okay.
Okay, this is.
Darshis.
Oh, I don't know, because this one is like a penguin or a polar bear.
It's a penguin.
I would.
It's something random.
It is a penguin.
Yeah.
It's a penguin.
Then
This
what?
is a little fat penguin. This is a little slim penguin.
And this is a panda.
Looks like on
That's a bear. This is a squid, somewhat maybe like squid. And a frog. 2 more people are still choosing their characters and naming themselves. Quickly join. I want at least 10 people to join the game.
Yeah. This link you can put it in the free group as well. Who is yet to join? Eight players connected. So, who is yet to join? So there are 15 here. 9 now.
Okay. One more.
One more.
More people. More can join. Yeah, you can share it in Ekya Vidya group.
I think we can start, I guess.
Wait for another minute and then
Okay.
we'll start.
One more minute. We are waiting for one more person to make it 10.
Yes. One or how many ever.
Yeah.
One more person. Please. It's close. Very close. 9.
Okay, I think start from here. There is
Yeah. If nobody else is gonna join, I'm gonna start. Starting. Okay. Alright. Kepler 10b orbits.
we need to see the answers. No? So,
Yes.
go
Bring
down.
it.
Kepler 452, Kepler 22, Kepler 186, Kepler 10. So the answer is
And
there. You will know.
okay. 3 people got it right. How? It's simple.
Yeah.
Okay. Never. I'm going on to the next question. What is the radius of Kepler 10b? It's R1. Okay. If you paid attention, you would.
1.48, 1.57.
1.57, 1.37. So many sevens. One of them is correct. 5, 4, 3, 2. Okay, wow. Actually, I'm surprised. My couple people, 7 people got it right. Okay, maybe not 7, 6, 5. Kepler 10 is a star in the Dash constellation.
So it become 10 number now. Cassiopeia, Orion, Canis Major, Draco.
It is pretty simple. I expect. Okay, wait, 10 people? How do you know 10 people? Oh my god. No way. Kepler 10 and 10 people. The estimated age of Kepler 10 is 12 billion years. True or false? Did a spelling error? IIT. Okay. Well, last discovery was announced on. Everything is January. You just need to know exact date. I won't
Know
know
this
this.
answer, but I accidentally pressed it long.
Okay.
The answer is here. Don't actually fall for it. It's not the answer. Nobody got it right, I think. Okay. Kepler-10b is the second confirmed terrestrial planet to have been discovered outside the solar system by the Kepler Space Telescope. True or false? Please don't make a mistake again. It's a minute detail that is the single word that changed the answer. And how it got it right. Okay, what is one of the methods used to discover Kepler-10b? There were two methods. One of them is here.
Gravitational measurements and astrometry, direct image, radial velocity.
What is the surface temperature of Kepler-10b in Kelvin?
Surface temperature of Kepler-10b 1834, 1982, 1838, 1832. What a twist.
Alright. Okay, ninth question. Kepler-10b can be colonized. True or false?
Niche, another Priya.
Okay. What is the answer?
Niche 6,000 mark. Wow.
Okay. And first answers were discovered on dash.
Planets
Dash.
some planets were discovered.
I also forgot the answer. What is I only forgot. Right. Okay. Oh.
Okay, he given he showed a slideshow. Might have the answer.
Yes, but I suppose you couldn't able to locate it. Okay. Diana Valencia considered Kepler-10b as more of a dash than a dash. Yes, yes. Answer is here. The answer. Okay. Yes, Ranadeep is the winner,
Yeah, I think last question.
followed by
Anish.
Anish and Riya, then Tarun, Matyesh, Adrit, Dash, Bhairavi, Shwarya, and Satyaki. Good job to everyone. And I'm just going to end the
Okay, who wants to show the audience perspective, the leaderboard?
I
Like the
closed it.
winners.
I don't think it will come now.
The podium? I don't.
Yeah. Podium won't come.
No, sir, I.
Sure, share it.
If you got a screenshot, maybe.
Nice. Okay. Sakti has it.
Okay, wait, why? Okay.
I just saw the image.
Yes. It was visible for 1 split second. You won't have to rewatch that and you like to know.
So if anyone took screenshot, just share it in the group. Okay, thank
Yes.
you so much, Naman. That's a beautiful presentation. That's a part 12 of planets of solar system and beyond. Thank you so much. Let's give a huge round of applause for Naman. All of you can go unmute. And 1, 2, 3.
Thank you, everyone.
Thank you. Okay, now
Amazing presentation.
welcome our new presenter, the first live presentation. And the presenter is Yashwin Tilbert, and he's a grade 8 student from St. Michael's Academy. He is going to present on this topic, James Webb Space Telescope. Okay, so a little introduction on who is Yashwin Tilbert. He is a level 6 student in offline programs. That means he completed almost 2 years learning aeronautics, aerospace, and rocketry. And he is currently building his one basic in situ model. That's a cube satellite. Then he is next level. He will be building rockets. Okay, Yashwin, I think you can start.
So can I present?
Yes, please.
Hello, my name is Yashwin Tilbert. Today, I'm going to present about James Webb Telescope. The outline of the presentation is James Webb Telescope, science behind James Webb Telescope. The James Webb Telescope. About the James Webb Telescope. The James Webb Telescope, also called as JWT or Webb, is an orbiting infrared observatory that will complement and extend the discoveries of the Hubble Space Telescope with longer wavelength coverage and greatly improved sensitivity. The longer wavelength enable Webb to look much closer to the beginning of time and to hunt for the unobserved formation of the first galaxies, as well as to look inside dust clouds where stars and planetary systems are forming today. Functions of the James Webb Telescope. It will see back in time farther than any space telescope ever has before. Back to the first light following the Big Bang. It will watch the first stars and galaxies form, and it will hunt for distant habitable planets by seeing through their atmospheres. Science behind the James Webb Telescope. The end of the Dark Ages, first light and reionization, that means arrival of the first stars and galaxies. James Webb Telescope will be a powerful time machine with infrared vision that will peer back over 13.5 billion years to see the first stars and galaxies forming out of the darkness of the early universe. Assembly of galaxies. James Webb telescopes, unprecedented infrared sensitivity will help astronomers to compare the faintest, earliest galaxies to today's grand spirals and ellipticals, helping us to understand how galaxies assemble over billions of years. This is an example of spiral galaxies. This is an example of elliptical galaxies. Planetary systems and the origins of life. James Webb Telescope will tell us more about the atmospheres of extrasolar planets, which means any planetary body that is outside the solar system, and perhaps even find the building blocks of life elsewhere in the universe. In addition to other planetary systems, James Webb Space Telescope will also study objects within our own solar system. The birth of stars and protoplanetary, that means a gaseous mass rotating around the sun. James Webb Telescope will be able to see right through and into massive clouds of dust that are opaque to visible light observatories like Hubble, where stars and planetary systems are being born. About the Hubble Space Telescope. Named in honor of the astronomer Edwin Hubble, the Hubble Space Telescope is a large space based observatory which has revolutionized astronomy since its launch and deployment by the Space Shuttle Discovery in 1990. Far above rain clouds, light pollution, and atmospheric distortions, Hubble has a crystal clear view of the universe. Scientists have used Hubble to observe some of the most distant stars and galaxies yet seen, as well as the planets in our solar system. Note, the James Webb Telescope is in direct competition with the Hubble Space Telescope. Key facts: the James Webb Telescope is designed to see to the time when stars began to form in the universe. The Webb can peek inside galaxies. Scientists now are convinced that each galaxy has at its center a supermassive black hole. The Webb will search for signs of extraterrestrial life. Thank you.
Nice, nice. Anish has some doubt. Yes, Anish.
Like my doubt is like I got confused when you said it will look back into time.
Yeah, it has a longer wavelength, so it can look back.
Oh, okay.
For example, whatever you see from a distant galaxy, that is actually you are looking into the past.
Yeah.
How it means the light has to travel few light years to reach us. It means whatever you
Sir,
are.
I'll do a part 2 in detail, sir.
Okay, so he's going to do
Yes,
a
sir.
part 2 on details. Okay, fine. Then, okay, let's not. Okay. Yeah, that's the simple answer. So it's like whatever you see in these images are the distant past. So currently there's be something else happening there. Okay, done. So very well done. That's a first live stream presentation of Yashwin Tilbert.
Sir, I
Very
have a quiz, sir.
confidently done. Superb, superb. I liked it very much. So yeah, you have a he has a quiz as well. You
Yes,
can
sir.
share the quiz link.
1 minute, sir.
So the one more person I have to join. If she is not joining, I will take a session on how to use NASA foil sim. I think most of you might know, but those who are watching it new can learn today. It's like a very
Sir,
basic.
I have pasted the quiz link, sir.
Yeah. I put it in live as well. Wait for 1 more minute, we can then start.
So can I start?
Yeah, please start.
Yes, sir. James Webb Telescope is also called as options are James Webb JWT, JTWW.
Actually, the answer is in the question only.
Well done. Anish is leading. Next question. James Webb Telescope is an orbiting dash observatory. Ultraviolet radiation infrared. Let's see the answers. Leaderboard. Okay. Many have answered, yeah. Infrared is the correct answer. James Webb Telescope is in direct competition with the Starlink Hubble Space Telescope International Space Telescope. So instead of International Space Station, it is written as telescope, sir.
Yeah, I noticed.
Yes, sir.
That's okay.
Many have answered Hubble Space Telescope. That is the right answer. Next question. James Webb Telescope will be a powerful time machine with infrared vision that will peer back over 13.5 billion years, 20 million years, 13.6 billion years. All done. Leaderboard. Anish is leading. Second is Matish and Nash. The correct answer is 13.5 billion. Next question. Types of galaxies that the James Webb Telescope can see. I mentioned it with a picture. Spiral, square, circle, ellipticals. All done.
Hi, Jaggu. Hello, everyone.
She's leading. Somebody answered. 3 answered square and circle. The correct answer is spirals and ellipticals. Yeah, 6 answers. 3, 2, 1. What is the meaning of extrasolar planets? Any planetary body that is outside the solar system, a selected planetary body that is outside the solar system, an Earth-like planetary body that is outside the solar system. 2 have not answered yet. Yeah, 1 have not answered yet. All done. Will or Aishwarya is leading. Many have answered an Earth-like planetary body that is orbiting the solar system. The correct answer is any planetary bodies. 2 have answered that. James Webb Telescope will search for dash light. Human, extraterrestrial, robots. All.
Question படிக்கிறதுக்கு முன்னாடி ஆன்சர் முடிச்சிடறாங்க.
Aishwarya is leading. Someone answered human. 5 answered extraterrestrial. That is the correct answer. Yes, this is the last question. The first place goes to Aishwarya, second is Anish Noel, and third is Matish.
Matish. Nice. Well done, well done. That's a super presentation followed by a super quiz. And it's the first live stream of Yashwin Tilbert. Let's give a huge round of applause for Yashwin Tilbert. All of you go on mute. Nice, nice. Well done. So, Yashwin, you have a lot of options here. There are a lot of companies here which are waiting to take you in. So that's like there's Target Space, Aerospace Now. A lot of like there are 4 or 5 companies here. So that details you can get it in the group and you put it in that in researchers group. You can get those details. If you want to join any of those teams, you can join.
So I have another. I have to go out. Can I leave?
Yeah. Sure,
Yes,
sure.
sir. Thank you, sir.
Thank you. That's a wonderful presentation by our newcomer Yashwin Tilbert. So Kashika is supposed to join. She's yet to join. So till she joins, we are going to have one small hands-on training or a tutorial kind of thing to practice something called a NASA foil sim. So what you guys do, what I'm going to do, see, all of you, I think hope all of you in front of computer or mobile, that's fine. Just go to your so I'm trying to share my screen. So just in Google, just search NASA foil sim. Okay. So here I'm going to Google. I'm putting NASA foil sim. This is the small representation of foil simulator. What is meant by foil? So the students who are attending, aerofoil or any foil or any strip. So when someone asks how aircraft flies, you can tell them aerofoil shape. It's like a fish-like shape, which is responsible for the lift generation. So you can see that here. So how to use this? So here you can do a lot of things where you can see the flow and how much lift it produces, all these things. But I'll show it here like this. So for example, if I increase the angle, the degree, the angle of attack. So the blue lines and yellow lines see or the airflow. The more I increase the angle, you can see the lift value is increasing.
Riyaka create a one video about airfoil.
Yeah. So
I see.
now this flow is static. How to make this flow? Yeah, moving flow. So when you click analysis on top, you can see flight, shape analysis, select plot, size and all. In that, click analysis. Under the display, you find streamlines, moving and freeze. Click moving. Can you see the moving flow now? Or you can also make it as a 2D, 3D. So 3D is not quite well because this is a very old software. Now let's keep it in 2D and again go to the shape. So under the shape, when you click the arrow mark, you can find a lot of options. Aerofoil, ellipse, plate. I click ellipse. So you see ellipse, then plate, then cylinder, then ball. So you can find all these options. Now aerofoil has a lot of more options below. So when I zoom it in, you can find something called high camber. What is meant by high camber? When I click it, you will know what it will understand. So this is one of the theory sessions I learned when I was studying undergraduation. That time I did not know about the software. It took time for me to understand what is camber, what is the Scott line and all. When I click flat bottom, so this most of the trainer airplanes fall under this flat bottom high camber design. Then negative camber. This is like a fish, inverted fish. So for each of this, you can find the lift and drag values differ. When you put high camber, you can see the lift value is so high, 300K. When I put like negative camber, it goes like negative. Then curve plate, you can find all this. This is an option to change angle. And I put symmetry, this is like a symmetric aerofoil. If I go to flight, you can change the air speed. What speed it is, the air is going. You can change three things: Venus surface, Earth, or Mars, or underwater. All these things you can find. Then there is something called this is you can change the altitude. What is mean by altitude? Height. You can change the height. At what height? What is the airspeed? All the data you can find here. So when I change the altitude, so the lift value changes. So you can also edit these values, the pressure value and the density, viscosity, all this you can able to customize it. So this is like on mini wind tunnel to test something. When you design an unmanned air vehicle or a drone, you obviously need one what you need a aerofoil structure. So when I put 0, you see you don't see any of the lines, streamlines. If this goes to Venus surface, I'm putting at average day. Then I go to shape. Shape we already saw. In analysis, you can find like aspect ratio, lift correction, drag, all these things. Well, slightly technical, but for the students, it's like a nice software to explore. Where select plot, you can change, you can put graph. So you can use the lift versus angle. You can put lift versus camber. We can actually understand when I change the camberness, how the lift varies. When I change the angle of attack of the airplane's wing, how it happens. When you change the thickness of this aerofoil, what happens? All these things you can change. Lift versus speed, lift versus altitude. So as the height increases, what happens to the lift? Then wing area. So this is like an amazing software. Then size, the chord length, the length of the thing you can change it. So the chord in the length of the aerofoil, the foil or the any structure you choose. The span also you can change. So if you look at this changing, you just need to select the 3D view. So the 3D view, I select the increase the span, it becomes so big. When I change the reduce the span, see what happens. See, it becomes very small. Then go to geometry. You can see the graph data here. You can even download this data, actually draw hands-on. After drawing it, you can actually make one. You can cut using cardboard or balsa wood or metal, whichever works. Then this data. So see, whatever data you're getting, it's like actual research work, right? For each aerofoil, how is the lift, drag, all these things you can actually plot. So even though this software looks very simple, these are so many signs. You can learn a lot of things. Maybe you can try. I'm going to stop sharing now. If any of the students want to share their screen and show something using NASA foil, you are like most welcome.
Jago, can you share the link in group?
Yeah, I'll put it. I'll put it in group and I'll share it in the live as well. I'll also put it in the chat box. NASA foils. So this is the one. This shape is the one responsible for the lift generation. The Bernoulli's theorem. Yeah. So if anyone wants to share share your screen and show that you can do NASA foils, you can do that now. Who wants to try it out on live? Okay, I just posted the NASA foils in link in the live as well. So hope this session is useful for you. And we had 3 amazing presentations and all 3 look very professional. I never got a chance. I only got like 3rd year or final year of my bachelor degree to do all this presentation, to form a team, to build something. Now we are trying to create this environment or platform to gain that knowledge at this age itself. So when all this experience happened at this age, there's some magic going to happen in future. Okay, I think that's about today's session. So if anyone wants to share anything, you are most welcome. And thank you everyone for watching this live. And please do share this initiative, support us, share to as many people as can, because this is something like creating future of humanity, or building the blocks of future human space travel.
Yeah,
Yes, Rakshan.
Jagu, I want to show something to you after the live stream.
After the live stream, okay. Then thank you so much. Bye bye. See you all next week with new set of